back, problem 12. It asks for linearization of some function g. G is given by x times fx squared, where f is some other function with certain properties. The main point is, what is linearization? Linearization is basically equation of the tangent line. It is not equation, but the function which gives you the equation of the tangent line. What do I mean by that? Well, find the equation of a tangent line. The point given is x equals 2. When x is 2, let's find g at 2, right? G at 2 is 2 here and 4 inside. 2 squared is 4. So 2 times f at 4. But f at 4, we are told, is 6. So 2 outside and f at 4 is 6. In all, g of 2 is 12. So you want to find equation of tangent line at x equals 2, y equals 12. Find the slope and you have a point. Equation of the tangent line. Notice slope is derivative at x value 2. Y minus y coordinate equals slope x minus x coordinate. Solve for y. That is, the 12 goes to the other side. This function, the right hand side function, after you solve for y, that's called linearization. All I have done is simplified this. G prime 2 times x minus 2 times g prime 2 plus 12. So the right hand side function is called linearization. So to find linearization, you need to find g prime at 2, derivative of g at 2. What was g? G was x times fx squared. Well, so to find the derivative of g, you will need to use product rule here, x times. And for the right hand side, you will need chain rule. So you have product rule with chain rule for the second factor. Okay, let's start. Derivative of g. Derivative of the first p is 1. Second as it is, plus first as it is, derivative of the second. Derivative of the second means this calls for chain rule. Derivative of f with the object inside as it is times derivative of the object inside. That's 2x. So simplifying, you get 1 times fx squared is fx squared plus x here and 2x here. That is 2x squared and f prime x squared. So g prime x is fx squared plus 2x squared f prime x squared. Now my point is at 2, x equals 2. So g prime at 2 is f at 4. You see, 2 squared is a 4 plus 2, x is 2, another 2 squared, and here is another 2 squared, 4. So f at 4, my problem says f at 4 is 6. That's the first guy, plus 2 times 2 squared is a 4. What is f prime at 4? F prime at 4 is negative 4. So that gives me 6 plus 2 times 4 times negative 4. All that blah 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 gets me negative 26. That is my derivative at 2 of g. So I'm just plugging in g prime 2 to be negative 26. And I plug in negative 26x minus 2 times negative 26 plus 12. Negative 26x plus 52 plus 12. Negative 26x plus 64. That is my linearization. Remember, what is linearization? You essentially have to find equation of the tangent line, solve for y. Whatever you get on the right is linearization. For my problem, it is negative 26x plus 64. Okay. Next question talks about, I'm given a polynomial. Find the average slope on this interval and verify the mean value theorem. Okay, let's understand what that is. What's the meaning of average slope? Average slope, see, we don't know how the graph is, but at -1 you have some point, at +1 you have some point. However your graph be, average slope is the slope of the line segment joining the endpoints. Okay, so endpoints for -1, I'm going to find f of -1. That will give me 1 point. At 1, I'm going to evaluate f at 1 for the y coordinate. That gives me another point. So I have 1 point here, 1 point here. So find f of -1. Well, that's my function. I'm plugging in -1. I get -11. What about the other point? F at 1. Plug in x equals 1. 2, 3, minus 10, -5. So that's my second y coordinate. So 1 point, second point. I hope this is clear. That's my first x coordinate. Use it in your function f to find its y coordinate. That's my second x coordinate. Use it in my function f to find my second y coordinate. Second point, first point, find the slope. This minus this over 1 minus -1. Okay, so I've substituted -5 minus blah. That gives me my slope to be 3. That is called average slope. So again, what is average slope? Average slope is the slope of the line segment joining the endpoints of my curve. What does the mean value theorem say? Mean value theorem says if my function is smooth, right? It is differentiable in an open interval. It is continuous on the closed interval. Then the slope of this line segment will be same somewhere along the curve. Looks like here I have the same slope as the slope of the endpoints. Question is to find the x coordinate of that point. Well, I want slope equals the slope of this. I have found the slope of this line segment to be 3. So I want derivative to be 3. Well, find the derivative. 4x plus 3. I want it to be 3. So 4x plus 3, I want it to be 3. So subtract 3 from both sides. 4x to be 0. Divide by 4. My c is equals 0. Let's try. It's fine. Until next problem.